Today we're going to talk about some really interesting stuff about microbial pathogens. First, we're going to start out talking about the general principles of how pathogens cause disease and how we study them as scientists. And then we're going to transition and talk about one particular pathogen, which is called Staphylococcus, but it's a subtype of that called Staphylococcus, a methicillin-resistant Staphylococcus, or MRSA. So we start out with a case which illustrates some of the interesting aspects of MRSA. And that is related to the National Football League. So it's from your book, and it describes how in 2003, the St. Louis Rams, some of the players started getting infected abscesses. And you can see those in figure 23.1, where basically what they have is they had a scrape or a cut, and then the cut got infected and formed an abscess, which is a hard kind of knot and like a nodule in the skin that is formed by the immune system in response to the Staph aureus. We'll come back and talk about how those abscesses form and exactly what they are. To get rid of them, the football players had to have pretty robust antibiotics. Some of them even had to have them IV. And the situation got more serious, though, when football players from another team started also getting MRSA infections. So then they called in epidemiologists from the Center for Disease Control, which is known as the CDC, and those epidemiologists started swabbing all the surfaces in the football players' locker rooms, the training equipment, in the football players' nose, on their skin, trying to figure out what types of Staph aureus were around and whether the same types were on the surfaces as in the football players. They also took those isolates and tested them for antibiotic susceptibility. And first, let's talk about how that's done. That's shown in figure 23.3. So basically, this is a test, an antimicrobial susceptibility test, which is measured by disc diffusion. So basically what the CDC did was they took a swab and then they cultured Staph aureus and then basically after they cultured it, they spread it onto a petri dish with media. Spread. Really thick, so there's lots of bacteria everywhere on the petri dish. And then after that, they place antibiotic discs on the sample. And then they incubate. Let's put our antibiotic discs on there. And what they're looking for is shown in that figure. They're looking to see whether the Staph aureus is able to grow even around the antibiotic discs. And you can see that some of those discs, like at the top, the Staph aureus is growing right up against the disc. So that tells you that the staph is resistant to the antibiotic. So here in this case, we have some resistant ones. Some of the lower images, though, you can see that there's a zone of clearing where the staph was not able to grow. And that tells you that the staph is sensitive to those antibiotics. So you put different antibiotics on the disc, and this is way you can learn what antibiotics might work well to treat the staph infection. So that's really good information to have. In addition, they wanted to figure out whether all the football players had the same exact staph, whether it was consistent with the idea that they were all getting the staph from each other or from a common source. And so to do that, they did what's called pulse field gel electrophoresis. Pulsed field gel electrophoresis. And you can see that in the figure that's on page 2 that basically shows an example of pulse field gel electrophoresis. So this is basically what you're doing in this to do this analysis is you take you isolate the chromosome from your Staph aureus samples. You cut it with a restriction enzyme that cuts infrequently. the way you get these is basically they have big, long recognition sequences, so they don't cut very often. And then you run those samples on a gel. And you're not really looking for the sizes of the different fragments so much as the pattern. And so that figure 23.4 actually shows a gel that is normally, like it's basically running from left to right, running from the large to the small pieces. And what you can see is that there's certain patterns. If we draw, let's draw some examples here. Basically, all we're doing is looking to see whether the pattern of bands is the same between two different strains. So if we see the pattern of bands matches, then we know that basically the restriction enzymes cut in approximately the same place and the sizes all match up. And so these two strains are probably highly related to each other, or maybe even the same. But sometimes you might see another pattern. Maybe you see something like this. And this, so strains 1 and 2 would be highly related, and strain 3 would be different. And so if we went ahead and swabbed all the football players and we saw that some of them had strains 1 or 2 and some had 3, this would suggest that they weren't all getting the infections from the same source. And so by doing this pulse field gel electrophoresis, we can type different strains of Staph aureus and learn a little bit more about what are the different strains in our like in the football area or in the overall area we're analyzing. And so you can see on that figure that there's a strain called USA 100 and USA 200, and then all the other strains up at the top are USA 300 type. And you can see that all those are very similar to each other. And so if you look at the names that are on those, some of those are from the football players, and some of them are from other people in the US. And so what this is indicating is actually that there's kind of one strain type that's really common in the population, and this is USA 300. And so basically there's a couple of questions that are posed there. Where did the MRSA come from? Well, it could have come from the people themselves. It can colonize on skin, or it could come from the environment. What is the mode of entry? It enters through cuts in the skin. What factors contribute to its spread? We'll come and talk about that. How does it cause abscesses? We'll talk about that. The players were given multiple antibiotics because the strains are resistant to multiple antibiotics. So they got to give a bunch of different ones to try to find a way to kill it. And the other part is that the abscess is a really protected environment. And then we just ended talking about what is pulse field gel electrophoresis. We talked about how it is a way to look at basically the signature of the chromosome. And it's used basically to investigate whether strains in an outbreak come from the same source. At the end of it all, the CDC recommended a bunch of steps that the football team should take. They included washing your hands frequently and noticing when you have cuts if you have any sign of infection. And they made these educational flyers that are in the notes, like a good player will pass the ball and not staph, which I think is a very good motto for all of us.